Although you don't have to worry about if you had not known these terms, the problem will explain you all these terms also. Now it says that given a matrix and a target, you are given a matrix, as you can see in pink box. I am given a matrix and I am also given a number called as a target, which is my target number which I have to achieve. I have to return the number of non-empty, which means the submatrix which I should take should have at least one element. It should be a submatrix, which means it should be a continuous part of this specific matrix. As you can see, I can represent this as one of the submatrices, and I can just define, as in a matrix I defined the extreme left corner and the extreme right bottom corner. That's how I define a matrix. Same way I can define my submatrix also by some points x1 y1 x2 y2 by just saying, okay, just to say that, okay, it's a submatrix, defining its points. Now I am also saying that two submatrices are different when they have different any of the x coordinate or y coordinate. If anything is different for them, okay, these two submatrices are different. For example, in the question itself, you will see that you are given the specific matrix, input matrix. Now you are given a number as target. You have to figure out all these submatrices in the input matrix so that the sum up to target. You will see there are just 4. There are these 4 submatrices, but in the second example, when you have 1 minus 1 minus 1 1 and the target is a 0, now the answer says that you have 5 such submatrices. Let's see those 5. What are those 5? As you can see, this is one such submatrix which can actually sum to 0. Other one is this, other one is this vertical, other one is this vertical, other one is this entire matrix. So you can see that we have these 5 submatrices which actually sum up to our target. Okay, great. Now the very basic brute force solution. Again, whenever we say brute force, we just implement or do whatsoever the problem is asking us to do. The problem asks us that given you have a matrix and a target, this is the problem says, okay, this I will give you as a input. Now you have to return the number of non-empty submatrices that sum up to target. So my main task is to generate all these submatrices. So what I'll do, I'll generate all the submatrices, and when I'll generate, again, there can be a chance that you might be saying, Aryan, how to generate that again? No matter what, I will show you how to generate all these submatrices. Generating a sub-array is very easy, but generating a submatrix, it's not that easy, especially for the ones who are actually not much familiar about these. So I'll show the proper diagram for that. But meanwhile, we know that, okay, we have to generate all these submatrices, and then when I have generated that submatrix, I have to sum that up, which means I have to go on. Again, if I just ask you, give me the sum of all the elements of a matrix, you just go on to all the elements and then you just sum that up. What is this? You just sum that up in a variable and then you return that. So the same way, whenever you have got one submatrix, you just sum up all these elements of that submatrix and then you will compare. If that sum is equal to my target, then okay, it's actually a good submatrix for me. Now let's take a matrix. Now my matrix name is Papaji and my submatrices will be Bachaji. But no worries, I'll name it as a submatrix and submatrix only. So I have this as my main matrix. So as again, like I didn't want to take all these above examples, like these examples, like neither these examples. The reason is because it has very less submatrices which can actually result to target, and this is a very small matrix at the first place. So I just combine both of them and make a bigger matrix. Now I have to figure out all these submatrices formed. Now you will see that you will form all these submatrices. How? Simply, whenever you are not able to do something, just start doing a dry run. How? So I will start plotting all these submatrices possible. Okay, one submatrix is, okay, I just have one cell, I have 2 cells, I have 3 cells. Other can be, okay, I have one cell but starting from the first column, I have 2 cells, again first column, I have just 1 cell. So you saw, and again I can repeat that same. Again, this I did for the first row, but what about I include the first row, but my first row is actually extending to the next row also. Okay, for I started off from the first row, which means the row 0, but then it extended off to the size of 2. Okay, same, you can see it's just that it is extended, the size of row has become extended too. Okay, it is same. Again, you will see it is just row being extended, that's it, row being extended, row being extended. And the same way, again I extended my row a bit more. Now my row size has become 3. You can see extended, 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 extended. Now okay, you can see that all the expanding of rows has been done. Now what you can do, okay, go on to the next row. Okay, I'll go on to my next row. Now I am at row 1. Again the same, again exact same what you did for row 0, exact same I'm doing for row 1, and thus I'm able to generate all these submatrices. Okay, you can see I'm generating all these submatrices. Again at row number 1, which means the row index 1, you want to extend that to the size. Okay, then you try it for the bigger size, which is a size of 2. You're trying to extend that. Now Aryan, why not you extend it above? Because if you extend above, then it will be same as when you extend it above 1 to a size of 2. So it is the same way how you generate these subarrays, right? If I want to generate these subarrays, then I just take this, then this, then this. When these 3 are done, then I'll extend it. Okay, take this and then this, right? Then ultimately take this. So same way I'm extending it both horizontally and vertically in the same fashion. Cool. Now when entire thing is done, so as to just give a quick glance, this is how your all the pattern will look like. Now just for you to plot, I just plotted that. Now you started off with the row 0 and then you took the only the one row. You started off with the row 0, but here you took 2 rows. You started off with the row 0, but here you took 3 rows. Here you started off with row 1, you took 1 row. Started off with row 1, took 2 rows. Row 2, 1 row. The same way you actually generate for, you start off with the index 0, you take only one cell. Index 0, 2 cell. Index 0, 3 cell. And the same way in index 1, 1 cell. Index 1, 2 cell. And then index 2, just 1 cell. That is how you generate, the same way I just did for rows. But not only rows, I also did the same for columns. That column start 0, column size 1. You will see column size is just 1. Column start is 0, but the column size is now 2. Column start is 0, but the column size is now 3. Column size start is 1 and the column size is again 1. Column start is 1, column size is 2. Column start is 2, column size is 3. So you will see that it is how you will generate all these submatrices. And if you want to generate all these submatrices, it's as simple that you will just simply have to iterate on all these loops, and the same way iterate on all these loops. So if I just give a quick glance of the code, the same way, exactly same way what we did, we will keep, firstly we will initialize some variables, which is our answer, n, m and n. M is the number of rows, n is the number of columns. When this entire thing is done, I know I have to do a row start, row size, column start and column size. When this entire thing is done, I will have a submatrix. But my problem, it doesn't finish here. I have to find the sum of that submatrix also. So firstly, I just took my row start, that I can start off with this row, but but row start is one thing, row size will also be expanding. Okay, my row size will start from 1 and go up till the how much I can expand. So row start plus row size, it should be less than equal to m. That's how much how can expand after starting from that row start. How much I can expand starting from that specific row start. So with this I can expand my rows, and the same way I will do for my columns. The same way I showed you above, that column start, I'll just start off with the column as 0 and then keep on going, and the same for column size also. Now when this is done, this entire thing will give me one submatrix, but again you have to find the sum. So I will just go and make another function which will go and find the sum of the submatrix. Again, the start is the row start, I know the size of that specific row. The column start I know, and because that I know the column size. Now why this is needed? Because you need to know all the coordinates of that matrix. So for that you need to know the leftmost top point and the rightmost bottom point. So to know the leftmost top point, you know row start, column start, but to know the rightmost bottom point, you actually need to know the size, which means the height and the width of that specific matrix, which is height is this, width is this, and that's how you can actually know all the 4 coordinates of my entire matrix. But I just need 2, which is the extreme top left and the extreme bottom right. Now when this entire thing is done, my sum of submatrix function will actually go on and just iterate on all the elements. Again simple, iterate on all the elements in this specific range which I passed in, and will give me the sum as the answer. Again, but my problem says that if the sum matches the target, only then you should actually increase your answer count. So I'll increase my answer count only when my sum matches. Now so you will simply see that the time complexity will be nothing but O of m into n because of row and column start, O of n into n because of row size and column size, and again O of m into n because of the sum of submatrix, which is actually inside this for loop only. So it is nothing but O of m into n whole cube, and space O of 1. This will not pass in our constraints and will give TLA. But the prime reason why I focused on this specific, making the entire diagram for all the pattern, is most of the people just don't understand how this will be generated, because generating subarrays is very easy in comparison to generating submatrices, right? Cool. Now coming on back, that we know that okay, for sure it will not work. Now let's look back and read the question carefully. And so far you must have thought of, right, why I am relating so much, and why in the first place my mind itself start relating so much with the arrays itself, because this is a higher problem. As I showed you, it's a tougher problem than that of the arrays. So which means I can solve the easier problem, which means I can solve the array problem. So my problem was number of submatrices that sum to target. Rather than submatrices, now I'm saying it is a harder problem, which I have seen so far. Generating these submatrices itself was actually hard. Rather, what I should do is, I should generate these subarrays. Oh, because it's easy. So I know the shorter problem can be, or the smaller or the easier problem can be generating subarrays. So now I have, although again I have seen it, but maybe you might not have, but after this problem maybe you can go and check this problem also, that you have to generate the number, or you have to tell me the number of subarrays that sum up to my target, and the target is k. It is the exact same problem, it's just that it is on top of the array itself. But it is not required for you to know this problem. If you know, good. If you don't know, no worries, I'll tell you everything. So after this video, you should be very easily able to solve this problem also. Now coming on back, that you can solve it, it's just that rather than matrix, it is saying the same thing. Just give me the same thing for a for an array. Now if I go back and solve this existing problem, which is the exact same, subarray sum equal to k, I will have to find the number of subarrays which sum up to k. So for sure, I'll take the exact same input which they have taken, which is 1, 2, 3. I have these elements and I have to sum to my target. Now the brute force approach, as I showed you in the beginning, is I will start off with this, then I will find this, and then this, and I will have to find the sum. Okay, I know that I can have n square subarrays. For every subarray, I will have to go and find the sum. Now one optimized way is, while okay, this is one subarray. Now as I know that okay, next subarray will be like this, so rather than finding the sum again, I can just keep on adding the sum. Okay, I'll add a 2, then I'll add a 3, then I'll start off fresh, then I'll have a 2, then I will simply add a 3 in that. So this is, I can optimize my O of n cube, which means O of n cube is generating all the n square subarrays and then taking the sum, which is O of n time. So rather than generating, like taking a sum differently, while generating the subarrays itself, I can take the sum parallelly. That's how I can optimize my brute force approach to a O of n square approach to get all these subarray sums, and then I compare that with my k. That is one option. But still, there is a better solution, which is in O of n. Now brute force was O of n cube. Brute force better solution was O of n squared. I'm talking about only the subarray. But here the optimal solution will look like that you use prefix sums, because it's as visual as, and again that's a very standard concept. If you have not known it, bookmark this video, save this video, like this video, do whatsoever you want. Not like will not, but yeah, like can actually like put it in a playlist, like do whatever you want, but it's a very important video for you to know the prefix sum. It's a very important concept. Now the problem says that you have this. Now you should just try to take the prefix sums. I'll show you how the prefix sum actually work, but you should try to take the prefix sums, which means I'll take a 0, which means initially it's a 0. I'll take this element, I'll add a 1, then I'll add my 1. Okay, what's existing sum? Add the upcoming element. I'll add a 2, I'll get a 3. Then existing sum 3, add with the upcoming element 3, get a 6. So this is a prefix sum. Prefix, which means okay, going on from the left to right, taking a sum again and again. Now what this actually means internally is that you had a 0, you added a b, you got a a. You added a with b, you got a plus b. You added a plus b with c, you got a plus b plus c. Now if I ask you, bro, can you please give me the sum of this specific range? So I'm asking you, from this I to j, can you give me the range? So what you can do is you can subtract. Okay, when you have this prefix sum, so you can just go and say you want this specific range, you want this range sum. So what I can do, I can just subtract prefix sum of I minus prefix sum of j minus 1, and this will give you the range sum of I to j. How? Because you will see that okay, this is a plus b plus c, and j minus 1 is a. So if I subtract, I get a b plus c, which is the specific range, and that's how in O of one time you can get to know any specific range sum. But you might say, Aryan, again, the question was number of such subarrays. Now you are saying that for any subarray you can find out the sum. I can reverse that also. If for us, if I can know, okay, for that specific subarray what is the sum, then okay, if I know that this is the sum, then what is the subarray like, or how many number of subarrays will be there, I can easily reverse that too. Now this is how it will work. For example, that if I know this is the prefix sum right now, you want the number of such subarrays which sum up to target. So I know that if I should do a subtraction of the prefix sum of j minus 1, I should be getting a target. So I can just bring this, because this is a question mark, this I am not sure about. So I can bring this here, I can keep this here. So prefix sum minus target should be a number which I should search for in my left. In my prefix sum array, in my left I should search for. So I'll just search for this number called as a, let's imagine my prefix, I was at this specific prefix sum which is 3, and I want to search from target as 3 itself. So I can search for 3 minus 3 which is 0. I can search for a 0, and I can see I have 1 0 in between, like 1 0 before, which means I will have one sub array starting from that specific 1 to this 3, which means from this specific portion I will have the sub array like whose sum will be equal to one target. That is how you can actually use a prefix sum. Other example for a quick one, that if you have your I here, then you will just say, okay, prefix of I minus target which is 3, you have to search for a 3. Okay, you found a 3, which means this specific portion will give you a range sum of 3, and you can see also that this portion will give you a range sum of 3, which is the target which you needed, and that's how you can simply solve it. So to know, okay, that is just one occurrence. But if I had 3 multiple times, let's say 3 would have been here also, so this specific portion would also have given me a array, like sub array sum, which is actually equal to my target. That is how this existing problem will actually be solved with this simple concept. Again, make sure that this can give you the occurrence also, number of occurrences. How many number of 3s were there? That will be the number of sub arrays which I can actually form ending at this index I. Coming on back to our basic example. For sure, we learned one thing, that a prefix sum can help us in 2 ways. Again, bookmark this, screenshot this, take whatsoever you want, pause it. But remember this, prefix sum can give you 2 things. First thing is that I can get the range sum. I can get the range sum very fast. When I say very fast, I know, okay, I can get the range sum in over one time. Again, when you have to do queries, that will not work. In that case, you have to do use a Fenwick tree or segment tree, but I'm saying the queries will remain, like the updates will not be there. Now when you want, and you know, okay, you can get the prefix range sum very fast. That's one use case of it. Other use cases that I can get to know the number of the ranges at that location which can give me that specific target sum. Both are actually the same thing. It's just to represent a same thing which I told above, that if I am at I can get to know from this to this. I want to know the range sum. That is very easy for me to know in over one time. From when I know, okay, this is my I, this is my j, then I can get to know this is the range sum in that range. Now I am saying I have my I have my answer which I want here, target. I can get to know what are all the possible j's. Same thing, right? Yeah, that's the same thing which I am saying. This is a 2 use case. Now let's use both of them one by one. So now Aryan, how would you know that you want to use it? Because if you remembered, our main problem was that we are going on to all these submatrices. We were generating all these submatrices, and when a submatrix is generated, we were going and finding the answer. We are going and finding the answer as in the range sum for that submatrix. Okay, we are finding the range sum. So we can actually utilize and use our prefix sum to find the range sum. So what I did was, okay, I know that I can find the range sum super fast, and I know, okay, I have to go and find my submatrix sum, which is nothing but a range sum, range in I and range in j. I have to find its sum. So rather, let's use the prefix sum concept here itself. So what we will do is, we will convert the matrix into the prefix sum matrix. If you had remembered the above example, we showed a matrix 1 2 3. We converted that to a prefix sum as, again, remember to place a 0 in the beginning, because 0 is false short there by default. 1 and then 3 and then 6. How a prefix sum will work, like same I will do for all the rows of my matrix. I will generate the prefix sum. Usually in the ideal case, you should not modify the input matrix unless your interviewer asks. So in the interview, ask the interviewer, sir, or XYZ person, the term called as sir is not applicable in the industry terms, but you can just ask him that would you like to modify the input matrix so as to utilize the space. That's it only. But in production, it's not actually like it's not a good practice to modify the input data. But in the code itself, I will show you by modifying it. But you can actually make a new matrix itself. So what we will do is we can make a new matrix, and I can simply take the prefix sum. Okay, 1 will be there, 1 plus 2, 1 plus 3. So 1, 2, 3. Again for the next row, minus 1, minus 1, minus 1, minus 1, minus 2, minus 1. Sorry, minus 2 plus 1. Minus 1. Okay, last row 1. Okay, 1, 1 plus 1, 2, 2 minus 1, 1. So this is my prefix sum. Again, prefix sum for all the rows have been made. Now I'll ask you, how will you easily go and identify the range sum, which means a submatrix sum? How will you do that? How will you optimize from that? So you can simply say, Aryan, if I want to find the range sum, let's say of this specific portion, right? This specific portion, I have to find the range sum. So what I can do is I can know the sum of this row. So this row I can find from my prefix sum. So I know minus 1 is there, minus 1 is there. So the range sum for this portion will be nothing but minus 1 minus of minus 1, which is a 0. And the range sum for this bottom part is 1 minus 1, which is again a 0. So I'll simply add for both the rows, because both the rows contribute their individual prefix sums, and that will be a 0. And then you can also see that the answer for this specific row is a 0, which means the sum of this specific row is a 0. Now, one thing which you might have thought of is, Aryan, that seems okay, but because of the above prefix sum which you have taken, you are only, although you are not going on to all the columns, but still you are going on to all the rows, which is actually again time consuming. Okay, hold on, you know that's a great part, but hold on for that. We actually go on to it later. But let's see with a few more examples at how your actual prefix sum range matrix sum will look like. That let's say if you want to find this specific range sum, so again you will go on to this range and this range. Again, row range I can find with my prefix sums, because I have taken the prefix sum of the rows itself. Cool, no worries. So what I'll do is I can know this specific range, which is 3 minus 1, so it is a 2. This row, like next row, minus 1 minus 1, which is a 0. So this I'll simply add, I'll get a 2, and you can see the sum is a 2 for this specific range, for this specific submatrix. Last example, want to find this specific row sum. Okay, minus 1 minus 0, I'll get a minus 1. 1 minus 0, I'll get a 1. I'll simply add them, I'll get a sum as 0. That is the sum of the specific matrix. Now, with this you have known that, okay, you have not gone to all the columns, but still indirectly you are going on to all the rows. That is what you are doing, right? You are still going on to all the rows and finding the individual prefix sums. Did you remember one thing I taught? Although you know one thing so far right now, that you will not go on to all the columns now. This part will be gone. This part will be gone. Now you don't need to go on to all the columns. Now you can use a prefix sum, but still there's one more catch from which you can optimize and not even go on to all the rows. You can just parallelly maintain your prefix sum. What was that catch? If you remembered in the very beginning, I showed you, if you want to find, okay, one way is that I get all these subarrays and then I find their sum. For that, okay, I'll take a n square time and then O of n time to find their sum. Other catch was, while generating or moving on to my next subarray, I can just add the upcoming element. So if I had a 1, I go on to my next subarray, I can simply add a 2, then simply add a 3 in my upcoming stream of sum. Next, when I initialize, okay, I'll just initialize my 2 as some new sum, then I can simply add a 3 for the upcoming element. The same way I can do for my new matrix approach also. How and what? So see, let's say if I am at this specific range, okay, for this specific range, I can easily, because it's just one row, it's just one row, I can simply use my prefix sum to find the answer. It will be a 1 minus 1, which is a 0. Okay, my prefix sum says right now, sorry, 1 minus 0, which is a 1. So my prefix sum says right now my sum is 1, and you can see, sorry, it's a 2, it's a 2, 3, 2 and 3. Just forget the prefix sum value I have changed it. 1 2 3 minus 1, 1 2 3 minus 1. Okay, let's forget it. Just have a quick correction. This is the actual you know, our sub prefix sum values. This is not correct, but it's just to show you the essence that how will you actually move in it. Yeah, please, but yeah, please correct it. It's not the actual, I just mistakenly wrote these values, but yeah, this is the actual correct value. Now coming on back, we are saying that we can utilize that moving thing. Okay, I'll move on and then I'll find the answer. How? I was at this specific first row. I know, okay, I just have to find the answer. So I can simply find the answer from the prefix sum. This minus this. I'll get my sum. Then I'll go on to my next row. Now, when I say next row, I mean, okay, from this first one is already there. Next row it has come in. So when you know the next row has come in, so why you have to go and again find the first row answer? No, right? Simply add the new row's answer, and with this you will get the entire matrix prefix sum. Okay, I'll simply add this contribution. Again, when I will go here, oh, I remembered. I copied the wrong thing. Oh, but no worries. Yeah, that's it. Like, cool, no worries. But yeah, I actually, so basically, what I said by copying the wrong thing, because initially when I made this matrix, I by mistakenly made the matrix, and then I realized that I did the prefix sum as wrong. So then I corrected it, but then I copied here the incorrect one, which I already made. But no worries, this is the only change here. When the third element will come in, then what you will see is that I'll simply add the third element in the previous element prefix sum. Let's say prefix sum was A. Here I will simply add a plus B. Here I'll simply add a prefix sum plus C, which is A plus B plus C. It will be added. So only C is added, only B is added, only A is added here. And that's how incrementally I can get my prefix sum. So with this, I don't have to go on to all the rows again and again. So with this, the entire thing, this also will be gone from here. Let's see the code. It's again pretty simple. I will be knowing this is the range. I see again. To know that this is the range, I will go on. Let's take this is the range. In this specific range of column start, column end. In this range of column, I will have to go and keep on applying and going on down, so that I can find, okay, this answer, then this answer, and then this answer. Cool. So firstly, I will maintain my prefix sum. Again, I just did it inside the same matrix nums, which is the input matrix, but I'll recommend you ask the interviewer first and then go ahead with modifying the matrix. So firstly, we'll do the simple prefix sum of all the rows. I'll simply do a prefix sum. All the, as I showed you above, I'll simply do the prefix sum of all the rows. When this prefix sum is done, I know that this is my entire matrix. This let's fix a specific column. When this column is fixed, again, when I say column is fixed, I mean the column start and the column end. Now to know the column end, you can use the column end also and column size also. Both ways you can use it. But when this entire thing is fixed, then you know that you have to go on to all the rows, which means you will go on to this row. When you go on to this specific row, you know that you will calculate the answer like this. Okay, this row, which means the answer is only for the first row. Then you will go on to my next row, but the answer will be of both the rows. Then next row, the answer will be of all the rows. Now when this is done, you will go on to my this row, which is the answer of only this row. Then you will go on to this row, which is the answer of this two, and then ultimately you will go on to last row, which is this. So you saw that you have your column, which will simply iterating saying O of n square, and you also have your row, which I showed you how I showed you. It will also go n square times, because you saw from row 0, then 1 size, 2 size, 3 size, row 1, 1 size, 2 size, row 3, 1 size. That's how you actually will go on. So I'll simply say my column start and column end. Again, you can also take the column size also. Again, that will work for sure. You will have a column start and column end, which will actually fix your column ranges. Okay, your column range is actually now fixed. Now you will go on and try for all the possible row starts. But when I say a possible row start, I mean this is a row start. This is a row start, but you will try this, then you will try this, then you will try this, which means you will incrementally keep on going. So row start is there. I initialize my sum, because you remembered my sum should actually keep on incrementally added. Right now my sum is S. Then it should, let's say an incoming element came as A. So I'll do a S plus A, which became a new S. Now I will, let's say I got a new element. So it will be a S plus B. So ultimately it is nothing but S plus A plus B, the new upcoming element. Cool. So I'll have my row start, which is this specific row start, but then I know that I will initialize my sum, but I will try for all the possible row ends. So row end is right now here, then my row end will be here, then it will be here. So, and next words, my row start will be here, then my row end will be here, and then my row end will be here. Next, my row start will be here, and my row end is here, and then how my actually row start and row end will actually move. And the same way, my column start and column end will actually start moving. So I'll simply keep on going and try for all the possible row ends, and will add the contribution of, and I will take the contribution of that specific row from this range to this range. Again, my range for the specific row is for this specific row, which is the specific row which I have taken. The range will be from column start to column end. So I know this for the specific row, this is my column start, column end, this is the range. So I'll simply go on and say the row end is my current row which I am at row start says, okay, row start says this is the row from which I am starting off, which means from which I will carry on and take my prefix sums, from which I'll carry on and take my sum and doing a carryover of that sum, so as to not go and compute the sum again and again. Row end will say, okay, right now, okay, my row started from here, then my row end will be here, so as to take only this specific row as sum. Then again, when I say this, I mean this specific sum. Then when my row end is here, I want to take this sum. When my row end is here, I want this specific sum. So you know that you are adding this contribution every time in your sum. In your sum, you will add this specific contribution. This specific contribution is nothing but row end, and for this column end to column start range. Now column end to column start is nothing but, imagine this as a simple matrix. This is the column end, this is the column start, and you want to find the sum. So it will be prefix sum array which you have built with your input matrix. It will be column end, it will be a row end because row is row end, and this will be column end because you know it's a column end which is last matrix, minus prefix sum of, again this is a specific row end, and again that will be column start minus 1, but you can do column start minus 1 only when column start is greater than equal to 1. Only then you can actually do it. So I'll do the same thing, that I'll just go on again. My nums is actually my prefix sum. If you have remembered, I've changed and modified my nums to my prefix sum. So this is my prefix sum right now. I'll just go and find this nums of this specific last value, and then again, if my column start is actually there, then go and find this specific value and subtract that, and then whatsoever you have got, that will be your current sum which you can add in your existing sum, because you wanted the range sums. And then if the sum matches the target, then simply increase the answer. So you saw that you actually removed this entire loop which you're actually using to find the sum. So now if you remember, you actually used that getting the range sum super fast concept of prefix sums. You used it, but that's great. Can't you use this directly? Because you want, again, what you are doing right now is that you are going and finding for all these submatrices the possible sums. But right now I'm saying, you know that you wanted a sum as target, so rather than finding all the possible sums, go and only find a sum as target. So what I will do is, now I know one thing, I was doing something wrong, and again, if you remember, the time complexity will be nothing but O of m into n whole square for this, because you see that you are going on to column start, column end, row start and row end, which is nothing but mn. That's the reason O of m into n whole square. Size, I'll again say space will actually be O of m into n, because right now I modified the input matrix. Because of that, the space will be O of 1, but in actual real world scenario, you will have to make a new prefix sum matrix. So you cannot modify the input. Now coming on back, that we will actually utilize that rather than finding a sum of all the ranges, simply go and find the prefix, simply go and find only the target sum. I'll simply go and find only the target sum, that's it. And how I will do it, I will simply try to utilize the same prefix sum concept which I learned for a specific array. Again, now because of this, utilizing the prefix sum concept, you will see that the prefix sum will be applied twice, and that's a whole part which no one teaches. I don't know why. And they just say, okay, you will learn the code, but that's not the case. Here you will see the entire thing. How? Let's see. So earlier, if I see earlier, what was happening earlier was happening is, I was okay at this specific row. Right now I was getting this one size. Okay, I'll just take, and this is the input matrix. This is the input matrix which I had as the base input. This is the prefix sum matrix which I made, so as to compute my row sum answer super fast. Okay, remember now how earlier I was doing. I was still at the row 1, but then I have to increase my row count. So I went on to my next row from row 1 itself, which means the row start is still a row 0, and then you will see, okay, I can get the new count. Okay, then the row start is still there, and then I can get the new my count. Okay, then I start off with this next row, which is the row 1, and then again for this specific row, again the row 1 is still there, but now the count of rows has been increased. Now the row 2. Okay, this is how you are actually doing, and that's and you can actually easily see that for every row you are going on to all the possible sizes. For next row, you are going on to all the possible sizes. For next row, you are going on to all the possible sizes, which is actually taking time for you. And it is the same way saying that for this specific For this specific cell, I'm going on to this cell, this cell, this cell. Then for this cell, I'm going on to this cell, this cell. For this cell, I'm going on to this cell. So this is the same way I'm doing it, right? You will see in this also you have 6 possible options, and in this also you can see I have 6 possible options. And you remembered one thing, right? That you don't need it. You don't need it. You can just only go to one cell I and then simply go back and look. So I was using this so as to utilize and not go on to all the cells of this specific row so as to find the sum. But yeah, that is, I can see it is the same way I'm expanding it and trying for all the possible 6 options. I'm just converting this entire thing as a matrix so as to relate that with the array. How in array it is actually being used, or basically it is actually being wasted. Now, the same way I'm doing. But if you remembered, this is nothing but same way saying that you are doing O of n square to go on to and try for all the possible sums which you want as a target. But then you also remembered the main use of the prefix sum array is that if I am, let's say at this, if you remembered at the above example, the prefix sum looked like 1, 3 and 6, right? Now, if I want to know the sum of, if I am standing here, I want to know the sum of 3 has occurred or not, which means the target of 3 has occurred or not. I'll just say my prefix sum right now is 3, my target is 3, so I just want a number 0. If number 0 has occurred, okay, number 0 and 0, as you can again remember in the prefix sum by default 0 is always there. So I know, okay, a 0 has occurred, so for sure I will have a sub array. And again, that will be just one sub array. If 0 would have been here also, then okay, I will have 2 sub arrays. But yeah, I will have one sub array which will actually give me a sum as target as 3. Okay, if I am standing here at the index I know, okay, I am standing here at the index I, which is value has 6. I want a target of 3. I want a 3 value. So if I go here, which means this specific range, and if you remember, the input looks like 1, 2 and 3. So this range was giving me a sum of 3. So you know that by using a prefix sum, you only need to get to an element just once, and I can simply go and ask what is prefix sum of I minus target value, and if it is there previously or not. If yes, and how much is the count of that? Let's say the count of 3 would have been 2. So I would have said ending at this specific index, I will have 2 subarrays whose count will be like, I will have 2 subarrays whose target sum will be a 3. So that is what I will actually utilize right now. How? See, right now, if you remembered, I will actually go on. Okay, I was going on and saying that this is specific array. And if again, remember, this was what we were doing. Now what we will do is, okay, if I am at this specific array, I'll go and check for my previous. Have I found that specific sum? Again, remember, I will shrink it and combine it to an array. I'll show you how. But right now I'll just say, okay, I'll just go and ask back. I will not go again and again on all the loops. I'll just go and ask back, have I found this specific target? If yes, then give me the frequency. And the same way, let's say if I go on to my row 2, then if I am at this specific row 2, right now with the standard case which we were doing earlier, technically I would have to go on to my row 2 also, and then this also, entire group. But that will not be required because now I am using a prefix sum. So I'll be staying at the row 2, and then I'll be asking for the count. Okay, give me the count of that prefix sum minus target. What is the count of that value? Let's say I am at the specific I. So I will compute its prefix sum of I. I know the target value which I wanted ultimately, that is given in the question itself. This is the result. Let's say this is the result. This is the, let's say subsidio, like SC. Let's name it as find, FND. So FD, let's say find. So I want to find this value previously, and how many times it occurs gives me that how this will be contributing, 1 or 2, how this will be contributing. Now coming on in the last one, if I go on the last one, it is the last cell, it is the last row. Then for this or for this, I will simply be getting the answer by this specific range only. Again, remember, I was only counting for my count start to count end, count start to count end, count start to count end, sorry, column start to count column end. So you saw that this will for sure again be fixed. My column start column end is still fixed, but then still I am going on to my rows. And it's just that rather than going on to all of my subarrays, I just need go on to my first cell, so like first row, second row, and the third row. That's it. Rather than all these n square, I just only need to go n. That is it, which means this and this, and from that I can actually use and find my answer. Now a quick example of how I actually do it. if you go back and look at the prefix sum, so I just want, okay, I just want this, I'll convert this. This is a matrix. Again, remember, this matrix is already a prefix sum matrix. Again, on top of it, I will make another prefix sum. That is the entire idea of this problem. This is, if you remember, this is already a prefix sum matrix of this input matrix, pink matrix. I made a blue matrix, sorry, I made a white matrix, which is a prefix sum matrix of all the rows. With that, I actually utilize that to get my range sum very fast. But then on top of it, I will make another prefix sum matrix to find the actual target values, how many such sub arrays are there in very less time. How? I know, again, make sure that you know that your column starting, column end is fixed. So no matter what, n square, let's say your n was column, so n square will for sure come. If you remembered in the previous thing, m square was also coming because of the row which you were going, because you remembered I was going on to all the rows again and again. M square factor was also coming. So that m square factor I'm trying to reduce to m. That's it. So I know one thing for sure, that this is my entire matrix, which is the red, which is this entire range, and I'm at this specific index. I know this is entire range. I can shrink it to one array. Simply, I know, because this specific range sum I can simply find by 2 minus 1, 2 minus 0. So this will be a 2, a minus 2, a minus 2 minus 0, minus 2, a 2 minus 0, okay, 2. So this is shrinked. This is the white one was a prefix sum array, but then I just shrink that to just represent or to visually show you as a one array. But remember, again, it's just a one array. It's just a one array. But you remembered at index I, you are actually going in from here to here. Again, you made the prefix sum like this. You made the prefix sum horizontally. But then you are saying that for I, you want to go and find the answer very fast. So you remembered that you are having your array vertically. So you need to make up your prefix sum vertically also. So what I will do is, I know this is my prefix sum which was made horizontally. So now I will make this prefix sum vertically also. So what I will do is, I have got this as a new shrinked array. This is for your visual representation. Then I will go on and shrink and make its prefix sum array vertically also. You will see a 0 in, again, 0 in the beginning will for sure be there everywhere. Then a 2 will be there, a 2 minus 2, a 0 will be there, a 0 plus 2 will be a 2 there. So you saw I just got a vertical prefix sum array of the horizontal prefix sum arrays. Again, from the input array, I made it the horizontal prefix sum array. I got it as a shrinked array. Then I made the vertical prefix sum array. And then I got the specific array. And from this specific array, I can go and find it the answer. How? Simply. Now, let's say if this is, I am at the specific index I. I want to search for a target. Now, let's say my target would have been any number. Let's say 0. Because if you remembered, in an array of 1, minus 1, minus 1, 1, I wanted my target as 0. So let's imagine my target is simply a 0 here. So right now my element value is a 0. My target is a 0. So I am going and looking for the 0. Before this index, how many 0 have occurred will give me that how many such ranges are there. So I can see before this index, my 0 occurrences are actually just 1. So ending at this index, giving me my target sum as a 0, I will have just one sub array, or ultimately saying one sub matrix. So one thing you for sure know, okay, you want to have the count or the frequency of the elements which has occurred previously. So you will have to keep track using an unordered map of this entire row. So you know that you have a row size of n. Your number of rows are n, so for sure you will have your unordered map, which will actually, you can actually store m elements. So you will have to store the frequency of all the elements which has occurred. Now when this portion is done, when you will go on to I, simply you have encountered one more 0, so simply increase the frequency of 0 by 1, and that's how you can actually keep on going on. So that was the entire crux. Firstly, you made the prefix sum of the horizontal, and then the prefix sum of the vertical. If we go back and look again, the most of the code remains same. A quick change will be that the prefix sum will remain exactly as it is. Again, here I modified the input array, but you can make a new array also. Unordered map will be used to keep track of the frequency of all the elements. This column start, column end will exactly remain same, because as you remembered, column start, column end, just say okay, this is a range. In this range, I will actually be utilizing and modifying and doing my time complexity as less. Then I will take the current sum. If you remembered, the same current sum which I will take, this is the unordered map initialized to 0, because if you remembered, 0 by default will be there. 0, if you remember, 0 by default will be there. And current sum is also storing this actual sum. Current sum is storing this actual sum. Current sum is storing this actual sum, which I will be making like this, going on. Now if I come back, I will go on to all the rows as I showed you one by one. So I will go on to all of my rows one by one. As you remembered, this is my prefix sum array, which is made vertically. Remember ultimately, let's imagine this is made. Let's imagine, although right now it is not made, but yeah, let's imagine this is made. So I'll go on to all my elements incrementally. This is the row. Okay, so I'll go on to all of my rows one by one to find the sum of one of the rows. Again, this is my current sum. If you remembered, current sum, I simply need to add. Current sum is just nothing but the prefix sum vertically. So, but for the current, for this row sum, you will simply use what? Simply use your matrix prefix sum. So for this row sum, which is this first row, you know your column end is here, you know your column start is here, and you know this is your current row. So this row sum will be nothing but this matrix, which is prefix sum of this row and this column end, minus prefix sum of this row and column start minus 1. This is the row sum, which is value 2. This is value 2 for this specific row. So this is the value 2 for this specific row, which is this value root 2 for this specific row, which I have added. Now I'll simply add again. When you are at here, again, go and try to find how many such previous element, how many such previous, if you are at this specific 2, go and find out how many of such previous places are there via which I can actually make my sum as target. So I can simply go and ask him, bro, can you please give me? So he will say, bro, right now your sum, this sum is this value, which is this current, which is, again, I'll show this in my current sum. So I know this is again plus, because current sum is actually the prefix sum also. So current sum will actually show this. Now I'll say current sum minus the target is my expected find value, which I will find previously. So my map of 0 was 1, only my map of 0 was 1. So I'll just go and find this 2 minus 0. I could not find 2 previously, so okay, he will not contribute anything in my answer. Okay, go on and move ahead. Now this is I. Again, the same concept will apply here. Again, whenever I'm going I, please also make sure that, okay, map of 2 has been increased, because now you have encountered 1 2, and then 1 2 can be used later on for someone else. So the same way, you will see that, okay, I'm simply adding my current sum. My answer will be added whatsoever I can find. I want to find is nothing but current sum minus target. It's the find thing which I have to do. What is the frequency of that find thing? Just simply add that frequency in my answer. When this thing is added, okay, just simply update the current sum frequency by 1, because the current sum, which is actually vertical prefix sum, you have found. This is the horizontal, this is storing horizontal prefix sum, with which I can find the current row sum in a range, and then I am storing the current sum as the vertical prefix sum, and thus I can simply find my answer ultimately in the end. And that's how I can simply, again, I will go on to all the columns, which means columns are column end for sure will be there, but now I'm going on to all those just once, and that's how I can actually reduce my time to O of m into n, which is reduced quite a lot. And a space will be again O of m into n for your prefix sum, which you will make. Right now I just did not use it, so you can say O of 1, but you will have to make in your code. And O of n for your unordered map will for sure be there, because you are actually storing a prefix sum. Either make a new sum array or use a prefix sum, but you have to store it and make new sum, like new vector. And that's how you can simply solve it. Again, the video has gone pretty long, but the only motive for me was to show you that how you have made the horizontal prefix sum, and how that horizontal prefix sum is actually utilized to make a vertical prefix sum, and also just to make you sure that how you can use your prefix sum later in the future, and also just to make you sure that how you can actually utilize the horizontal and vertical prefix sums, which means just, okay, this is the array, how you can visualize your array like this and like this. Cool. Thanks for watching. See you. Goodbye. Take care. Bye bye. Oh, that was a very long video. I don't want to, like, people have made 11 minutes video, and how I'm making 15 minutes video. That's insane. That's not right actually. Like, people like me as a person, I actually go and firstly watch a 15 minutes video rather than a 15 minutes video. But I'm not doing right, but yeah, no worries. Bye bye.